Hello, very quickly, here is how you would make a factor tree to work out a prime factorization. So, if you want your tree to go up the way and look like an actual tree, you need to start at the bottom of the page. That's really important. So we're at the bottom of the page here, start with a little stem, and how about we do the number, let's say 30. Okay, now you need to think of any two things which could multiply to give 30. So that's any two factors of 30. I see that it ends in a 0, which means it's definitely divisible by 10. So let's go for 3 and 10. So 3 times 10 would give me 30. 3 is prime, so that branch stops there. You can leave it like that, or if you like, you can put a little circle around it so that you know that branch is done. 10, however, not prime, so we can keep going. 10 ends in a 0, which means it's definitely even, so I could split it into a 2 and a 5. And now I check these. 2 is prime, so that branch is going to stop there. 5 is also prime, so that branch is going to stop there. And finally, what I can do is I can now write 30 out as its prime factors. So 30 is equal to 2 times 3 times 5. Okay, let's do another one. We can make a whole prime forest. So, how about we do the number, let's go with 42. Very interesting number. So, what can 42 definitely be divided by? So, any two factors of 42, I'm going to go with 6 and 7. Seven is prime, and 6 is going to be 2 and 3. So I could write 42 as 2 times 3 times 7. Okay, final one. We're going to finish up with 360. So remember, starting at the bottom of the page, we're going to have 360 and a little stem there. Now you might recognize this as the number of degrees in a circle. And the reason 360 is the number of degrees in a circle, one of the reasons anyway, is that it has a lot of factors. There are loads of different ways that you can split up 360. So this is called a highly composite number, or sometimes called anti-prime, because it's like the opposite of a prime. So many factors. So I am going to split this up, first of all, into, I'm going to go with 5 and 72. Now that might not have been your first instinct, but the great thing about factor trees is no matter how you split them up, as long as it is correct, so 5 times 72 does give 360, we will end up with the same answer if you had started with 36 and 10 or 180 and 2. And I think you should try that in a second. Okay, 72, how can we split that up? Well, it ends in a 2, so it's definitely even. If I were to half 72, that would be 36. So that's going to give me a 36 and a 2. 2 is prime. And now my 36, it's a square number, I like it, so I'm going to split it into 6 and 6, neither of which are prime. And now I'm going to split those up into 2 times 3. So 2 times 3 would give me 6, both of them are prime. And same for this 6 over here, I'm going to have 2 and a 3. 2 and a 3. Okay, how do we write this as a prime factorization? Well, let's just start in order. So 360 is equal to, how many 2's do we have at the end of our tree? 1, 2, 3. So it's going to be 2 times 2 times 2 times 3 times 3, 3 times 3 times, and we've also got a 5. Okay. I can then go ahead and write this as, this is for bonus points, 2 cubed, because there are 3 2's, times 3 squared times 5. Okay, now you go and try and split up 360 in a different way. Don't start with 5 and 72, you can start with anything else, and see if you get the same answer as me. Enjoy!